Imagine a blind man working in a restaurant. His job is to make smoothies, but he's only allowed to run the blender, not fill it with ingredients. He has a mischievous co-worker to hand him the blender, who sometimes puts random things in the blender to prank the blind man. After falling for the prank for a few times, the blind man learns to shake the blender before running it, to check if there's anything unusual inside. Over time, he gets so good at it that he can tell even if there's a hair in the blender just by shaking it. Now replace the blender with a gearbox, the hair with an anomaly, and the blind man with an AI agent, and you have yourself a gearbox audio quality detection system. Volvo Construction Equipment is one of the world's largest manufacturers of construction equipment. It makes gearboxes and transmission axle components. At the factory, the gearboxes go through a quality inspection test at the end of production, where workers listen to audio recordings of the equipment to determine whether there's been a fault during the production process or not. Kind of like the blind man shaking the blender to see if there's anything weird inside. This, however, poses two major problems. First, the operators must listen through the entire recording, which takes up a lot of time. A computer, on the other hand, could run an algorithm on the recording to detect anomalies in an instant. Secondly, even if we had all the time in the world, the operator's judgment is always subjective, meaning that even the slightest distraction or error in judgment could send a faulty piece of heavy-duty machinery into the field, which could cost a lot of money or even lives. On top of that, the switch from humans to software is easy to implement and it saves money in the long run. The audio consists of 3 recordings for each gearbox. The first 2 provide a control for the ingoing and outgoing sounds in decibels, providing the limits for the test. And the third is the actual gear test, which is listened to by the operator. The current solution converts the audio signals to spectrogram images and uses autoencoders, which is a type of machine learning model to detect anomalies. However, the data used by this approach is labeled by human beings that again aren't very reliable. To improve upon the solution, we plan on using unsupervised learning approaches to classify different kinds of defects and label these classifications with the help of experts. Audio analysis using various signal processing techniques and artificial intelligence may even allow us to determine the location of the defect, saving time on repairs as gearboxes are massive pieces of equipment with multiple components and a lot of moving parts. Our team plans on developing the anomaly detection system along with an intuitive user interface, allowing the operators to seamlessly test the equipment for faults and find the exact location of the problem without ever worrying about what's going underneath. If successful, this technology can be transferred to various other industries and change the landscape of quality testing forever.
Created using Powtoon.